So now in this video we have an NE555 timer here on the board that is controlling whether a PNP bipolar junction transistor is on or off. So when you're powering with 5 volts, it's best to have 5 volts at the base to make sure that the PNP bipolar junction transistor is off fully, which we appear to have right now. So I can pull the jumper right now. It's actually turning on and off rapidly. And we go to the positive supply, it's on completely. So let's go back to the negative supply. That turns the PNP bipolar junction transistor off because we have a high output there. I have a pull-up resistor though, that is making sure we got 5 volts. So there it's off completely. If I remove this, so we still have a high output, but it's not making all the way to 5 volts. And you can see my body provides enough stray signals to now activate it, where it would not do so with the pull-up resistor earlier. And now we're going to take a voltage measurement. So first we're going to take it without the pull-up resistor. And if you've studied 555 timers, you know they commonly don't get all the way to the positive supply voltage. And just by measuring the voltage now, we got enough where we are getting a some current through the transistor. We want to make sure the transistor is fully off. So now we have our pull-up resistor right there. The output is still high, and you can see we are close to 5 volts there. So that's practically 5 volts. That makes sure that the transistor stays off fully. So now zooming in to get a closer look at the circuit, we have to power the integrated circuit, NE555 here, positive supply to pin 8, and then the negative supply, ground over here, to pin number 1. Positive supply is also known as VCC. Pin number 4 is the reset pin. We don't want it to reset. That will connect the output to ground and stay there if we get a low input to 4. So pin number 4, the reset pin, we just put directly to the positive supply so that it does not do anything. Now when it comes to the input, which determines what the output is doing, we got pin 6 and pin 2 tied together right there. They're looking for a couple of voltages. So when we have the jumper, in this case, directly to the positive supply, you could also use a single pole double throw switch. We have, with the 5 volts, a low output. So it connects to ground, which it does really well. We don't need any help there. But if we move the jumper to the negative supply, as you can see there, right now the output is high. So it connects to 5 volts at the output, but unfortunately not perfectly. And so it's actually like 4 volts, maybe a little bit higher sometimes. So what we do with the pull-up resistor is now, as long as we don't need any current flow, which we don't get with the PNP bipolar junction transistor, positive over there, because the emitter over here is positive. You need a small amount of emitter to base current for a lot of emitter to collector current. So you're not going to get that when the base is 5 volts right there. Current doesn't go from positive to positive, only from positive to negative, or you could think of electrons as going negative to positive. And pulling back, you can see we got the pull-up resistor, positive supply coming to the output, pin number 3, 1, 2, 3. 10K resistor can be a relatively high value resistor because we're not depending on current. Then we have the 10K resistor there coming from the output to the base of the transistor, and that's to allow a little bit of current to flow from emitter to base and then to the output when it's connected to ground, when the output is low. So we have the emitter up here. This is a 2N3906. Exact transistor doesn't matter, but it is a PNP bipolar junction transistor. So the emitter is to the positive supply. So that is the top pin. Middle pin is the base. And sometimes when we lose a little connection or something, you may just a temporary cut, you may see the LED come on a little bit while I shuffle things around. Power is still on. But in case we got the base there, collector down at the bottom. The order of the resistor and the LED do not matter. So I got the LED first, long lead the anode, more positive, short lead the cathode, more negative, and then the resistor coming to ground because it makes a better jumper than LEDs do for the most part, a resistive jumper. But I also added this little drawing right here to just kind of illustrate. As you saw when we measured with the multimeter, when we were really close to 5 volts, practically 5 volts, the LED was completely off without question. But as we dropped, close to about 0.6 volts, this is probably when it would be on completely, 0.6 volts. But as we approach that point, then the LED started coming on a little bit. Transistor started conducting a little bit. And once we dropped below 0.6 volts, less than 5 volts, so like 4.4 volts or less, the LED would be on completely. The PNP bipolar junction transistor would be on completely. So that pull-up resistor just helps make sure we actually got 5 volts, especially because when you need at least a little current, you don't even get anywhere close to 5 volts with the NE555. There's other 555 timers, CMOS versions, that can get to 5 volts, but they can't really provide any current. So you may want to use those, but they're also more expensive. I think a pull-up resistor might solve a lot of problems you have if you actually need to get to that 5 volts without much current.